Grigori Grabovoi patents method of prevention of catastrophes and device for its realization, information carrying system in the ensuring of eternal development. Grigori Grabovoi patents method of prevention of catastrophes and device for its realization, information carrying system in the ensuring of eternal development. 230, 40, 26 pages. Method for prevention of catastrophes and device for its realization. Use for prevention of catastrophes of natural or man-caused nature. Essence, the signals of luminous radiation from the element, which corresponds to the zone of the assumed catastrophe, are processed by means of an optical system, which contains sensors produced, for example, from rock crystal, made in the form of identical cubes, allocated in the direction of spread of radiation and placed in a glass sphere. The last cube, by means of an optical fiber, is connected with a sensor, which is connected to the processor system through the amplifier. Normalized radiation is formed in the optical system. It is preferable to carry out scanning of different sections of the element, made, for example, in the form of the maps of the area. In this case, the zone with the increased characteristics of normalized radiation corresponds to the section of the rise of the catastrophe. Thus, for catastrophes of natural nature, the section of the origin of the catastrophe has characteristics exceeding radiation characteristics of other section of the element by 20 to 28%, and for man-caused catastrophes, corresponding increase makes 10 to 12%. Technical result is the increase of the effectiveness with the simultaneous expansion of the field of application of the declared method and device. Description of the invention. The invention can be used for prevention of various catastrophic phenomena, both of natural nature, such as, for example, catastrophic earthquakes, and man-caused catastrophic phenomena, in particular at production facilities. The closest, based on the technical essence, to the declared one is the method of prevention of catastrophe of natural origin, that is an earthquake, by means of registration and processing of signals, which characterize the situation in the zone of the assumed catastrophe. C of the USSR number, and so on. Vibration signals in the form of fluctuations of the Earth's crust, which emanate from the focus of the earthquake, are processed in accordance with this method by means of the grid of seismic receivers by receiving electrical signals. The received electrical signals are transformed in the center of collection, registration, and information processing into control signals, which are delivered to the emitters made in the form of vibration sources. Produced or normalizing signals in the form of elastic wave fluctuations are directed to the zone of the seismic center. The damping of the seismic fluctuations is realized as interaction of the high frequency elastic vibrations which emanate from the vibration sources, which the low frequency wave fluctuations from the seismic center. The disadvantage of the known method is its low effectiveness, since counteraction to the catastrophic earthquake is realized only when it is developed to a sufficient degree. Due to this, it is necessary to receive in advance a number of prognostic signals in the center of collection, registration, and information processing. Furthermore, the known method possesses limited functional capabilities since it can be used only for prevention of earthquakes, and it is unfit for prevention other catastrophic phenomena, for example, of man-caused catastrophes. The closest based on the technical essence to the declared one is the device for prevention a natural catastrophe that is an earthquake, which contains converter of signals, which characterize situations in the zone of the assumed catastrophe, the system of registration of the signals, and the emitter, which generates signals which facilitate normalization of the situation in the zone of the assumed catastrophe. Vibration pickup that converts mechanical fluctuations which appear with the earthquake into electrical signals, the value of which is proportional to the amplitude of the mechanical fluctuations, is used in this device as signal converter. The system of processing of signals consists of preamplifier, the units of generation of basic frequency, the block of automatic phase tracking, in which the useful signal is phase shifted to 180 degrees, and the driver amplifier. The emitter The emitter is made in the form of vibrocompressor, which generates fluctuations that are in the reserved phase with fluctuations appearing with the earthquakes, which contribute to the normalization of the situation in the zone where the earthquake struck. The disadvantage of the known device is its limited functional possibilities, since it is applicable only when a catastrophic earthquake strikes. Furthermore, the operation of this device entails high expenditures as a result of uncommonly high power consumption, caused by the need of emitting powerful mechanical fluctuations within a rather long period. The objective of the present invention is the increase in the effectiveness of the method of prevention of catastrophes, which simultaneous expansion of the functional capabilities of the declared method and device, used for its realization, and reduction in the expenditures for the realization of the method. The solution of the indicated problems is ensured by the new methods for prevention of catastrophes by the way of operational forecasting of a nascent catastrophe and production of signals which normalize the situation in the zone of the assumed catastrophe. The new method for prevention of catastrophes is realized by means of the new device. In accordance with the invention, the method for preventing of catastrophes is realized by means of registration and processing of signals, which characterize the situation in the zone of the assumed catastrophe. In this case, the signals of luminous radiation from the element, which corresponds to the zone of the assumed catastrophe, are processed by means of the optical system, which consists of sensing elements made from the oriented crystals located consecutively in the direction of the received emission. Moreover, they form in it normalized emission for normalizing of the situation in the zone of the assumed catastrophe. In this case, it is preferable to conduct continuous scanning of different sections of the element which corresponds to the zone of the assumed catastrophe, determining the section of rise of the catastrophe based on increase in the radiation characteristics emerging from the optical system in comparison with the radiation characteristics of other sections. The section of rise of natural catastrophes should be determined based on the increase of the radiation characteristics which correspond to the section by 20 to 28% in the comparison with the radiation characteristics of other sections. The section of rise of man-caused catastrophe should be determined based on the increase of the radiation characteristics of corresponding to this section by 10 comparison with the radiation characteristics of other sections. In accordance with the invention of the device for prevention of catastrophes contains a converter of signals which characterize the situation in the zone of the assumed catastrophe, the system of registration of signals, and the emitter which generates signals which facilitate normalization in this zone. In this case, the signal data converter consists of the element which corresponds to the zone of the assumed catastrophe and the optical system which contains sensing elements produced from the oriented crystals located consecutively in the direction of the received luminous radiation, which are made in the form of identical cubes, mutually displaced and having different, direction of the received luminous radiation, which are made in the form of identical cubes, mutually displaced and having different orientation of optical axes. Moreover, the corresponding planes of the cubes are located in parallel.
Use the glass sphere, okay. The glass sphere which contains the cubes form a transparent structure with the glass sphere, and the sensor of normalized emission connected by means of the optical fiber with the last in the direction of the emission propagation cube. In this case, the sensor is connected to the processor system, supplied with the program package of processing of the sensor signals. In this case, it is preferable to produce the signal data converter in the form of combinations of the optical system and the map of the area where the assumed catastrophic earthquake is to take place. The signal data converter should be produced in the form of combination of the optical system and the system of telemetry with a monitor that reproduces the element corresponding to the zone of the assumed man-caused catastrophe. The program package of the processor system should be supplied with all possible parameters of the zones of the assumed catastrophe. The present invention is based on the developed by the applicant theory of wave synthesis in combination with the formula of general reality. See the Doctors of Physics and Mathematics thesis by GRIGORI GRABOVOI, Research and Analysis of Fundamental Definitions of Optical Systems for Forecast of Earthquakes and Catastrophes of Production Facilities. Moscow, Publishing House of the Russian Academy of Natural Sciences, 1999, pages 9 to 19. In accordance with the theory of wave synthesis, the reality can be considered as periodic intersection of stationary areas with dynamic ones. In this case, the synthesis of the dynamic wave with the stationary one takes place in the zones of intersection. In crystals, a similar process makes it possible by means of solution of the universe problem to obtain from the stationary medium in the form of a crystal the dynamic components of wave synthesis. The phase of time, the specific three-dimensional arrangement of crystals, normalization of the medium, which is a source of certain element of light, takes place. Thus, it appears to be possible to normalize the medium, information about which is contained in the element of light. Furthermore, it is possible to determine the time of the deviation from the norm after the resources of the optical system have been exhausted. For example, to determine the time of the earthquake or catastrophe. The use of the emitter in the form of the microprocessor contributes to normalization of the situation in the zone of the assumed catastrophe. Normalization of the situation in the zone of the assumed catastrophe is achieved by means of the optical system that receives information from radiating medium. The optical system consists of orientated crystals located consecutively in the direction of the received luminous radiation. Either the map of the area or the system of telemetry with the monitor can be used as a radiating medium. With the entering of light from the radiating medium to the sensing elements of the optical system, the initial action of normalization of the radiating medium by the first crystal occurs at the moment when the element of light emanating from the third crystal passes through the fourth crystal, and the following action of normalization is accomplished with the passage of the element of the light through all crystals. Light is selected as a data carrier due to the fact that this will make it possible to visualize and to record the laws of connections determined by the formula of general reality. The process can be intensified by the use of laser emission. The sensor of normalized emission, made for example in the form of the temperature sensor connected with the last sensing element, can be used as the resource of obtaining of output information. Registration of the signals which enter from the sensor is carried out by means of the processor system, which is connected with the sensor and emitter. The use of the packet of programs in the processor system, which contain all possible parameters of the zones of the assumed catastrophes, makes it possible to increase the effectiveness of the declared device. In the general case of the declared method and device, make it possible to convert to decrease or to prevention the information in the form of light pulses about the catastrophes, both of natural and man-caused nature. In this case, prognostic and prevention of all possible catastrophic phenomena can be carried out from any point of space. The enclosed drawings show in Figure 1 the arrangement of the sensing elements in the optical system. View in the projection of the plane OX, OZ, where OX is the horizontal direction, OZ is vertical direction. Figure 2 is the arrangement of the sensing elements in the optical system. View in the projection of the plane OX, OY. Figure 3 is a general view of the device used for realization of the method for prevention of catastrophes. The device contains sensing elements 1, 2, 3, 4, 5, 6, and 7, manufactured in the form of cubes of the same size located in glass sphere 8 and forming with a monolithic transparent system, optical fiber 9 that connects the last sensing element with the sensor of the normalized emission 10, laser 11, element 12, which corresponds to the zone of the assumed catastrophe, manufactured, for example, in the form of the area map, amplifier of signals 13, which enter from the sensor, established at the entrance of the process to system 14, supplied with the package of programs of signals processing that enter from the sensor that is connected to display 15 and to the emitter signal 16, which facilitate normalization of the situation in the zone of the assumed catastrophe, and object 17, which generates biosignals. The number of sensing elements in the optical system can be chosen equal to 7, 14, and the like. Sensing elements 1 to 7 are made from crystals, for example, from rock, crystal, or diamonds, and are made in the form of cubes of the same size. For example, the length of the cube face 20 millimeters. During fixation of the cubes by the material of the glass sphere, 8 lateral faces of all cubes are located in parallel. The arrangement of cubes 1 to 7 in sphere 8 and orientation of their optical axis are selected so that the prevention of catastrophic phenomena occurs, for example, of earthquakes with realization of harmonization. The cubes are shifted in 2 mutually perpendicular planes as shown in figure 1 and figure 2. The output parameters of the optical system are recorded with the use of a sensor of normalized emission 10, located from the side of sphere 8, reverse in relation to the inverted to the map area 12. It is preferable to manufacture sensor 10 in the form of low inertia, high sensitive film element, which is used, for example, as a temperature sensor. The use of laser 11 makes it possible to increase the accuracy of the measurement of the signals entering from sensor 10. Application of the object, which generates biosignals, additionally contributes to normalization of the situation in the zone of the assumed catastrophe. The work of the device is considered with the description of the declared methods for prevention of catastrophes. In accordance with the declared method, the luminous radiation emanation from element 12 that corresponds to the zone of the assumed catastrophe, manufactured, for example, in the form of a full-scale map area, is directed to the optical system, which consists of glass sphere 8 with sensing elements 1 to 7 inside of it. The sensing elements are made from orientated crystals located consecutively in the direction of the received luminous radiation. With the conversion of the luminous radiation in such optical systems, see figure 3, isolation of the maximally normalized form of light volume occurs. Normalization is achieved with the passage of the element of light through sensing elements 1 to 7. Mutual arrangement of sensing elements 1 to 7 causes harmonization of this light volume. That in turn normalizes the situation in the zone of the assumed catastrophe. In the case of the degree of decrease of catastrophic phenomenon corresponds to the value of the normalized light volume. Signals from the sensor of the normalized radiation 10 after the passage through amplifier 13 are transferred to processor system 14, which contains the package of the programs of processing of the entering signals. After processing of the signals, the image of characteristics of the signals is received in display 5. When a catastrophic phenomenon is being forecast, emitter 16 is activated and additional signals which facilitate normalization of the situation in this zone are sent into the one of the assumed catastrophe. It is preferable to conduct continuous scanning of different sections of element 12, which corresponds to the zone of the assumed catastrophe, by means of sequential radiation absorption, which comes from element 12 at all sensing elements 1 to 7. The section of rise of a catastrophe in this case is determined by an increase of radiation characteristics of this section in comparison with the radiation characteristics of other sections. When a natural catastrophe is arising, for example, an earthquake, the section of origin of the catastrophe has radiation characteristics that exceeding by 20 to 28% the characteristics of other sections of element 12. If characteristics of radiation increase by less than 20%, no catastrophic phenomenon will occur. And if characteristics of the radiation increase by more than 28%, a conclusion about development of a catastrophic phenomenon of extraordinary nature can be made. In case of rising of a man-made catastrophe, for example, connected with upsets of technological cycle of a nuclear reactor, the section of the origin of the catastrophe is determined based on the increase in the radiation characteristics by 10 to 12%. If the characteristics of the radiation increase by less than 10%, no catastrophic phenomenon will take place. With the increase in the radiation characteristics, while the increase in the radiation characteristics by more than 12%, an extreme course of events can be expected. Examples of realization of the declared method with the use of the pre-production model of the declared device are given below. The device contains the optical system, which consists of the glass sphere with 7 sensing elements consecutively located inside of it. The sensing elements are manufactured from the rock crystal in the form of cubes of the same size with the length of a 20mm face. The sensor of the normalized radiation is connected through the optical fiber to the last. According to the direction of propagation of luminous radiation cube, the sensor of normalized radiation is made in the form of a thin film temperature sensor. The sensor through the amplifier is connected to the entrance of the processor system, manufactured with means of accelerated calculation of four-fold integrator. Example 1, the rise of the catastrophic earthquake in Kamchatka region was examined. Glass sphere 8 was sensing elements 1 to 7 was placed at a distance of 250mm from the full-scale map of Kamchatka. In this case, the sensor of the normalized radiation 10 was located on the surface of sphere 8, reverse to that which was inverted to the map. The signals entering from sensor 10 passed through amplifier 13 and entered processor system 14, where they were continuously processed, recorded and derived to display 15. The measurements were carried out within the period, starting at 9:03 a.m. on the 26th of June 1999. An earthquake 5.1 in the Kamchatka region was forecast. The earthquake struck at 9:03 on July 3, 1999. In this case, the decrease of the magnitude due to the use of the declared device was 0.4. Example 2, under the same conditions as in the previous example, scanning of the element 12 was conducted. Element 12 corresponded to the zone of the assumed earthquake to the map of Japan. A struck of an earthquake measuring 6.2 was forecast. The earthquake struck at 9:03 a.m. on July 3rd, 1999. The decrease of the magnitude in comparison to the initial forecast made was 0.8. Example 3, the map of Alaska was scanned under conditions similar to those of the example. Precise time of the earthquake measuring 4.8 was forecast. The earthquake struck at 7:26 on July 4th, 1999. In this case, the decrease of the magnitude was 0.5. Example 4, under conditions similar to those given in example 1, scanning of the map of the Philippines was conducted. The precise time of the earthquake measuring 4.0 was forecast. The earthquake struck at 13:32 on July 4th, 1999. The decrease of the magnitude due to the use of the declared device made 0.2. The analysis of the received data shows that in all cases, complete confirmation of the forecast phase 7 days prior to the beginning, with a precise indication of the time of the beginning of the earthquake was received. The value of decrease of the magnitude due to the use of the declared device was within the range of 0.2 to 0.8. The advantages of the declared method and the device for its realization are the increase in the effectiveness due to the precise forecasting of the beginning of the catastrophic phenomena and the possibility of remote normalization of the situation in the zones of the assumed catastrophes. Simultaneously declared method and the device for its realization have a wider field of application in comparison with the known ones, since they can be used for preparation and the prevention of catastrophes both of natural and man-caused nature, while complete ecological cleanliness will be observed with their use. Furthermore, expenditures for realization for the method are reduced as a result of simplicity of the operations of the method and the possibility of repeated use of the device used for the realization of the method. Formula of the invention. Number 1, method for prevention of catastrophes, which includes registration and processing of signals that characterize the situation in the zone of the assumed catastrophe, differs in its characteristic that it is processing of the signals of luminous radiation from the element, which corresponds to the zone of the assumed catastrophe, by means of the optical system, which consists of sensing elements made from the orientated crystals and located consecutively in the direction of the received emission. At the same time, they form in the optical system normalized radiation for normalizing of the situation in the zone of the assumed catastrophe. Number 2, method on page 1, which is characterized by the fact that the continuous scanning of different sections of the element which corresponds to the zone of the assumed catastrophe is conducted. In the case of the section of the catastrophe is determined by the increase of characteristics of radiation which emerges from the optical system in comparison with characteristics of radiation from other sections. Number 3, method on page 2, which is characterized by the fact that the section of the rise of the natural catastrophe is determined by the increase of radiation characteristics which correspond to this section and differ from radiation characteristics of other sections by 20 to 28%. Number 4, method on page 2, which is characterized by the fact that the section of rise of a man-caused catastrophe is determined by the increase of radiation characteristics in this section that differs from radiation characteristics of other sections by 10 to 12%. Number 5, the device for prevention of catastrophes which contains signal data converter, characterizing the situation in the zone of the assumed catastrophe, the system of the registration of signals, and the emitter, which generates the signals, facilitating normalization of the situation in this zone that is characterized by the fact that the converter of the signals consists of the element that corresponds to the zone of the assumed catastrophe and of the optical system, which contains sensing elements. Manufactured from orientated crystals located consecutively in the direction of received luminous radiation, the crystals are made in the form of identical cubes, mutually displaced and having different orientation of optical axes, with the corresponding planes of the cubes located in parallel, a glass sphere, which contains the cubes which form together with the sphere of the continuous transparent structure and the sensor of normalized radiation connected with the cube, last according to the direction of the propagation of emissions. By means of the optical fibre, moreover, the sensor is connected to the processor system, supplied with the package of programs of processing to the sensor signals. Number 6, the device, according to page 5, is characterized by the fact that the signal data converter is manufactured in the form of combination of the optical system and the map of the area where a catastrophic earthquake is supposed to strike. Number 7, the device, according to page 5, is characterized by the fact that the signal data converter is manufactured in the form combination of optical system and the system of telemetry with the monitor, which displays the element, which corresponds to the zone of the assumed man-caused catastrophe. Number 8, the device, according to page 5, is characterized by the fact that the package of programs of the processor system includes all possible parameters of the zones of the assumed catastrophes.